Welcome to 6WIND vRouter webinar, where we will discuss scalable VPN gateways for SD-WAN. My name is Eva Bonodo, and I will be your moderator for today's webinar. Joining me today are Kelly LeBlanc, 6WIND VP of Marketing, and Yann Rapaport, 6WIND VP of Product Management. You can ask your questions using the Q&A button at the bottom of the page. We will answer the questions at the end of the webinar in the order that they are received. Let's get started. I will now turn it over to Kelly.
Thank you, Eva. Hello, my name is Kelly LeBlanc, VP of Marketing for 6WIND. Today I am going to introduce 6WIND Scalable VPN Gateway Solutions for SD-WANs. 6WIND is a high-performance networking software company with a focus on vRouters for white box networking. Our vRouters are available in 3 different software packages. The first is our 6WIND Gate software, which is source code for Linux networking. 6WIND Gate includes complete and modular Layer 2 through 4 networking stacks. Here we help our OEM customers build their own vRouter technology and more, including a full range of additional networking equipment and solutions. The second are software appliances called Turbo Router and Turbo IPsec. These vRouters are ready-to-run appliances for customers who build and operate networks. In today's webinar, we will focus on Turbo IPsec. The third is hypervisor acceleration. These vRouters boost virtual networking and switching performance inside NFV platforms, such as Nuage Networks AVRS and Contron SimCloud. Our software runs on market-leading processors that leverage DPDK for performance, including x86 and ARM. We've been solving networking performance challenges for our network builder and OEM customers for over a decade now. Our customer list is impressive with a large global reach, including servicing over 90% of 4G networks in Japan, the top service providers in the US and EMEA, and more. These customers use our software with standard tools such as Linux on commodity hardware to solve some of the largest networking challenges in the industry. In today's webinar, we will discuss how IPsec vRouters can create scalable VPN gateway solutions for SD-WANs. I will start with a brief introduction of our Turbo IPsec vRouter features. Then I will highlight SD-WAN use cases where we are seeing success with our features, performance, and management. At the end, Yann will conclude with a product demo before we open the webinar for questions. 6WIND Turbo IPsec is a ready-to-use IPsec VPN software appliance and one of the most popular products in our vRouter family. It gives customers the performance to replace routing and security hardware with software on commercial off-the-shelf or COTS servers. 6WIND Turbo IPsec can be deployed in bare metal or virtual machine configurations with the same software. In recognition of our software performance innovation, this year we won SDN Product of the Year, and just this month, IDC named 6WIND one of 3 vRouter market innovators. To give you an example of our product success to create scalable VPN gateways, let's start with the Tier 1 service provider example. AT&T has been a 6WIND IPsec vRouter technology customer for 5 years. AT&T uses 6WIND's IPsec VPN software to create its virtual VPN internet gateway that creates secure VPN services for its customers. AT&T was an innovator to run this service in virtual machines versus deploying standard hardware. As a result, they've reduced their CapEx by 70% and are now using the same technology within their new SD-WAN services as well. Let's review a couple popular use cases where we have been successful creating scalable VPN gateways for SD-WAN. The first is a hybrid network data center deployment. Here we see a hybrid WAN and SD-WAN deployment with both Internet and MPLS networks. The SD-WAN solutions are deployed at the edge. 6WIND's Turbo IPsec vRouter provides the VPN gateway functionality in the data center and is orchestrated by the SD-WAN solutions. It also routes traffic to cloud services. The MPLS and Internet networks are both used together for cost-effective networking. 6WIND software-based VPN gateways are added in the regional data centers to create a secure overlay network over the Internet between the remote sites and the regional data centers. Secure site-to-site VPN tunnels are also created with 6WIND's high-capacity Turbo IPsec software. In certain cases, an overlay can also be created with 6WIND's Turbo IPsec over the MPLS network, independent of the content service provider. In this case, GRE or IPsec tunnels can be used to create the overlay over the MPLS networks. The second scenario is a POP deployment. Here, customers can create large and international private networks over the Internet. 6WIND's Turbo IPsec vRouter creates a global IPsec overlay network to connect the regional POPs and the sites to the regional POPs. This ensures any-to-any connectivity between the sites. VPN gateways are deployed in POPs located in different regions to connect the regional remote sites to interconnect the different POPs and to provide access to the cloud. 6WIND Turbo IPsec also ensures additional capacity for direct site-to-site tunnels. Now let's review 6WIND Turbo IPsec's features to create high-performance VPN gateways and software. 6WIND Turbo IPsec vRouter features include IPv4, IPv6 networking with support for VRFs, BGP, OSPF, dynamic routing, tunneling, NAT, PPPoE, and L2TP client server, ACLs, GRE, VLAN, VXLAN encapsulations, lag, high availability, and more. IPsec VPN functionality is available through IPsec and IKE features for customers that need secure VPN tunnels and connections between sites, data centers, or mobile infrastructure. You can see these features in the top left. These are the features used in our scalable VPN gateway solutions. Our customers also deploy 6WIND's Turbo IPsec vRouter as a security gateway, an edge router, a core router, within public and private clouds, inside SD-WAN solutions, and more. Now let's review our Turbo IPsec performance. Our security software performance is impressive at 12 gigabits per second per core on an Intel Xeon E5-based COTS server. If you need more capacity, simply add more cores. For IKE performance, we support up to 100,000 IPsec tunnels with a tunnel establishment rate of 1,000 tunnels per second. Today, you can get the same or even better performance running IPsec VPN gateway software in bare metal or virtual machines on COTS servers versus incumbent systems. 6WIND's IPsec VPN performance is impressive, and this is one of the reasons we've won so many NFV use case awards. On an Intel Xeon E5 processor, as mentioned, we deliver 12 gigabits per second of throughput per core, up to 100,000 IPsec tunnels, and 1,000 tunnels per second, all in software. And performance scales linearly with the number of cores, combining VRF, IPIP, and filtering to create IPsec VPN tunnels. With the same processor, we deliver 7 gigabits per second per core. And for customers who are now leveraging Intel's new Xeon Scalable processor family, you can see we increased performance by 50% on the new Intel Xeon Platinum processors. Here we can deliver 18 gigabits per second per core and 10.5 gigabits per second per secure VPN tunnels. It is the same 6WIND software that gives you a 50% performance increase on the latest generation processors. Now let's review 6WIND software management options. At 6WIND, we offer a choice of management options to meet your requirements for configuration, deployment, and monitoring. For configuration, 6WIND vRouter provides both traditional CLI-based management and IT management based on Yang and NetConf APIs for integration with higher-level orchestrators and management frameworks. For deployment, we provide packaged images for bare metal, KVM, VMware, AWS, and leverage the Linux Cloud Init and Ansible features to customize the system. Finally, for monitoring, we support the traditional SNMP and syslog mechanisms, plus data plane telemetry through SFlow and graphical analytics with time series database. Now let's review our management features in some more detail. 6WIND vRouter supports an industry standard CLI based on context for the configuration of the system and networking features. Help and completion are embedded in the CLI, as well as the management of configuration files to save and restore a complete and consistent configuration in one command. The CLI is actually a netconf client that communicates with our Yang-based configuration engine. Startup, running, and candidate configurations are supported. Data consistency is checked against the Yang model so that syntax errors are detected early. The engine supports transactions and rollback on error. Concurrent access is supported as well. The engine supports netconf, providing a programmable interface for scripting and integration with higher-level orchestration and management tools. Regarding monitoring, traditional granular polling, for example, to retrieve a single statistic, is of course possible using the CLI, netconf, or SNMP. Integration with legacy NMS systems through SNMP is possible. We also support data plane telemetry using SFlow, where data packets are sampled. Data plane packets are sampled, collected, and sent to a collector for analysis. This allows integration with third-party tools such as SolarWinds or Arbor's monitoring systems. Finally, the vRouter is able to stream key performance indicators to a time series database for analysis through a graphical front end. We have pre-integrated the vRouter with InfluxDB and developed dashboards for Grafana. This is public and available on GitHub to experiment with and contribute. This is just an example of a similar integration with other analytics frameworks such as Prometheus or Elastic, which is also possible. Here is an example of Grafana dashboard including network throughput, per interface in gouges, and for the complete system as curves, CPU utilization for both Linux and the data plane cores, and detailed statistics regarding the data plane for advanced tuning and debugging. Finally, for vRouter deployment, Day 0 packages are provided for initial deployment on bare metal using a USB stick, PXE over the network, or a bootable ISO image, or as a virtual machine with open virtualization images for VMware and others, or QCOW2 for KVM. Once the Day 0 package is deployed, one needs to perform basic system and networking configuration and provide console access. This is Day 1 configuration. By default, the vRouter has DHCP and SSH enabled on its first network interface and a set of default users with different profiles. This can be customized using Cloud Init or Ansible according to the customer's use case. Our documentation includes examples with AWS, VMware, and OpenStack. In summary, 6WIND's Turbo IPsec vRouter delivers the requirements to create scalable VPN gateways for SD-WAN solutions and much more. We have the performance with up to 18 gigabits per second per core of IPsec, the full set of routing and IPsec features, and virtualization readiness to deploy in bare metal or virtual machine configurations today, with a seamless migration path with the same software. 6WIND vRouter provides both traditional CLI-based management and IT-style management based on automation and integration with high-level orchestration tools. Our data models leverage Yang and are therefore easily understandable and extensible. Thank you for joining my presentation. Now I will turn it over to Jan for his demo.
Thank you, Kelly, and hi everyone. So in this demo, we will show you how 6WIND vRouter can be used to connect multiple enterprise sites. This is similar to the hybrid data center SD-WAN use case that Kelly described. 6WIND vRouter is installed at the edge of 3 enterprise sites and provides connectivity between sites and to the internet. BGP controls the routing tables Firewalling with NAT is used at the entrance of each site, and a VPN is used to secure the traffic between two of the sites. As you would expect from an SD-WAN solution, management is centralized for all vRouters. Monitoring takes place in a Grafana dashboard, and the whole platform is deployed and configured using the Cloudify orchestrator. For the sake of the demo, all systems are deployed as virtual machines in an OpenStack environment. The same demo could work in bare metal, in a private or in a public cloud, or any mix of these. Let's start by deploying the networking infrastructure. This is the Cloudify GUI that will be used to deploy the network and later the servers and configure them. Cloudify relies on blueprints or templates that modelize the networking use case. We are uploading the 6WIND vRouter network blueprint. Now, let's instantiate and deploy the blueprint. We use default parameters for the network names, IP addresses, and masks, as this is properly pre-configured for our demo. And at that step, these parameters can be customized for a different use case. The network blueprint deployment is now in progress. Once the deployment is complete in Cloudify, the vRouter network can be installed. That is, Cloudify can instruct OpenStack to configure the networking infrastructure. After the workflow is installed, we can see in Horizon, the OpenStack GUI, that the network resources have been created for the provider, private, management, and gateway networks. Let's now move on to server deployment and configuration following the same process. Let's deploy the 6WIND vRouter servers blueprint. This blueprint contains the model for the servers that will be deployed on top of the network infrastructure. As previously, we instantiate the blueprint with the default parameters. Here we can configure the subnet advertised by BGP, some Grafana information for the server that will be used for monitoring, the BGP AS IDs for the different sites, the version of the vRouter software that will be deployed, and more. After the deployment is complete, we install the servers as we did previously for the networks. Cloudify communicates with OpenStack to spawn the 4 vRouter VMs and the one for monitoring and analytics. In Horizon, we can see the corresponding OpenStack instances named Turbo Router 1 and 2, Turbo IPsec 1 and 2, and Grafana. The network topology shows how the vRouters are interconnecting using the network infrastructure previously instantiated. Now, let's look at the CLI configuration of one of the Turbo IPsec vRouters as automatically installed by Cloudify. Using the CLI, we dump the routing table, and we can see the BGP routes have been received and installed. The BGP table shows the network prefixes and next hops. We can see as well that ACLs have been configured to allow SSH, HTTP, HTTPS, and BGP traffic. Other types of traffic are blocked. And finally, if we dump the traffic on the interface connected to the other Turbo IPsec vRouter, we can see that IPsec is used as the packets carry an ESP encrypted payload. And now for the monitoring part. We open a browser to the Grafana VM, and we see the dashboard of one of the vRouters. We see network throughput on the different interfaces, CPU usage for both Linux and the data plane, memory usage, number of IPsec tunnels and establishment rate, and detailed data plane statistics for fine-tuning and debugging. This is the end of our demo. Now to Eva for the Q&A session.
Thank you, Jan. Let's answer the questions we received. So I kindly remind our attendees that you can ask your questions using the Q&A button at the bottom of the page. So the first question we received is the following. So can you leverage cryptographic hardware for high performance?
Yes, so thanks for this good question. The 6WIND vRouter supports both software and hardware cryptos who are able to leverage cryptographic hardware to implement high performance IPsec if the hardware is available. And if there is no cryptographic hardware, we can dynamically use the software implementation. So both software and hardware crypto are possible.
Very good. The next question is, how can your vRouter be integrated with SD-WAN management frameworks?
So we provide APIs for this. So it's true for SD-WAN, it's true for any kind of orchestration and management framework. Our vRouter provide netconf support. So it's a programmatic API, so you can interact with the vRouter based on Yang models to configure it and also retrieve information from the vRouter. And in SD-WAN, it's very important to support that kind of configuration, as one of the fundamental components of SD-WAN is a centralized management system.
Okay, thank you, Jan. So we have more time for the questions. So the next one is, what are the monitoring features for the vRouter that apply to SD-WAN?
Yeah, as you have seen in Kelly's slides, we support SNMP, SFlow, which are, I would say, some kind of traditional features for monitoring. We support syslog as well. And so specifically for SD-WAN, in SNMP, there is no standard for IPsec, and 6WIND has developed an IKE and IPsec MIB for SNMP. So that's one of the specificities of 6WIND vRouter for the monitoring in an SD-WAN environment. And we also have a very modern, I would even say next-gen monitoring features through our KPIs, for which you have seen in the demo and also in Kelly's slides. The ability to retrieve key performance indicators from the system and store them in a time series database for an analysis through a graphical environment, so that you can actually see the dynamics of the system over time. And so this is very important, and it's really a good benefit of the solution. So you can understand and correlate for a problem or some information, some statistics in your system with an event that occurred in the past, so you can better understand the system. And you can even predict the future, because you see the dynamics of the system, so you see the evolution of the system. And specifically for SD-WAN, so we have the throughput of the interfaces. We have, of course, all kinds of statistics you would expect. Plus, we have the number of IPsec tunnels and the establishment rate of security associations.
So the next questions are, for the SD-WAN implementations, do you offer different packages that are tailored to lower performance CPUs found in UCP?
Sorry, Eva, can you repeat the end of the question for the what?
Sure. So the question is, for the SD-WAN implementations, do you offer different packages that are tailored to lower performance CPUs found in UCP?
I can take this one. Thank you, Eva. So we offer our software according to capacity or throughput. So in fact, the packages are standard for all of our Turbo IPsec vRouters, starting at 1 gig with 1,000 tunnels, and going up to 100 gig with 100,000 tunnels. And this is both for perpetual and for subscription licensing.
Okay. Another question we received is, do you support DPI of application and configure applications over different WAN?
So a good question. So we don't provide the complete SD-WAN solution. We provide a component of the solution that is the security gateway. So we take care of the IPsec part, of the routing part of the solution. And typically, our Turbo IPsec is integrated with other solution that would do DPI. And that's what we are doing that's what actually our customers are doing to build their SD-WAN solution. So our focus is really on the IPsec, high performance IPsec and routing part of the solution.
So we still have more times for questions. So the next one is, should the vRouter solution for SD-WANs be deployed in bare metal or in virtual machines?
Both are possible. It's the beauty of a pure software solution. We support physical environments based on as Kelly said, Xeon or Atom CPUs, and also virtual machines. We can deploy our vRouters in KVM, VMware, Amazon environments.
Okay, thank you, Yann. I think we replied to all the questions. Oh,
I think I see another one.
Yeah, we just received another one. That is, does 6WIND Turbo IPsec router support MPLS functionality?
Yes, we have MPLS coming in our next release, end of October. So feel free to contact us if you want to see MPLS, some MPLS demo or evaluate MPLS in the next release.
All right, very good. If you have any other questions, you will have the ability to contact us. And if you like what you saw in our webinar and would like to evaluate 6WIND vRouter, you can submit your request in our online form at 6wind.com. On our website, you will also find our product information, regularly updated blog roll, and registration for our monthly webinar series. The webinar is now ending. Thank you, and we hope to see you again soon.